Here's an example PIC microcontroller project where a numeric keypad is being used to set the speed for a pulse width modulation driver for a small DC motor. Only 3 keys are being used on the keypad: the 1 key, the 4 key, and the asterisk. And the functions they serve are to increase or decrease the speed of the motor and to start the motor turning at that speed. By attaching the rows and column of the keypad through a network of resistors and a series capacitor, we can use the PIC Basic Pro POT command to read the effective resistance of the keypad at any moment. And that allows us to determine which key is being held down. The motor is a permanent magnet DC motor rated at 1.5 to 3 volts. It's powered by the same supply as the PIC, so it's 5 volts, but it's powered with a pulse width modulation signal that has a duty cycle. And to increase the speed, the pulse representing the on time is made larger than the remainder of the pulse where the motor is off. So by changing the duty cycle, or the percentage of time the motor is pulsed on, you can alter the speed of the motor. Here's a close-up of the electronics. We have the PIC microcontroller in the center. The motor is controlled by a MOSFET power transistor and is controlled by the pulse width modulation signal coming out of the PIC microcontroller. The microcontroller also controls these 4 LEDs. The green LED is the least significant bit, and the 3 reds are higher order bits. These bits provide a visual display of the current speed setting, which can vary from 0 to 15, because we have 4 bits. Finally, there is a switch that is used to stop motor motion and allow the user to readjust the speed. Here is the project in action. First, the power supply is turned on. As you can see, the PIC assumes a medium speed, in this case 7, because we have 1 plus 2 plus 4, so that's a medium speed in the 0 to 15 range. The user can increase or decrease that speed with these buttons. If I decrease down to the lower speed and press the enter key, the motor is turning at a fairly low speed right now. Again, it's controlled by a pulse width modulation signal. I can stop it at any time with the button input. I can now increase the speed a little bit by pressing the 1 key, and when I hit enter, the motor turns at a slightly faster speed. I can stop it again, increase the speed further. This is a medium speed. You can see the motor is turning much faster. And finally, we can increase it much more to a larger speed. And again, the motor is turning even faster.